Evening, my 12th standard warriors. Welcome to the first lecture of Light Waves with me, Shreyas, your physics master teacher. This is a term 2 topic, but we have kick-started the term 2 syllabus with electromagnetic waves. So it's a good time we cover up at least few of the topics of term 2, and we'll again start the term 1 revision before your board examinations. Term 1 syllabus is done in the Pathfinder series. Yes, that's right. If you have seen this logo, this is for class 12 standard long-term series on YouTube just for all of you. So do not forget to watch all the lectures. In case you have any conceptual misunderstanding or need some clarity and you want to solve some more problems for practice. Not just that, you will also get advanced problems in these playlists. So go ahead, check out the channel playlist which is there, right in the other tab. So you have different tabs, videos, playlists, about me, etc. So go ahead, check out the playlist tab. And those of you who do not know me, I am Shreyas, I am the physics math teacher. Hello Aishwarya, Dinesh, I am very good. Hi Hari, nice to see all of you. And 5:30 is our usual time for conducting 12th standard classes. The 11th standard classes go on for physics I'm talking about. So the 11th standard classes go on at 7:30. All right, so let's get started. Are you all excited to start the next chapter? Because this is term 2 syllabus, and if you're all excited, go hit the like button down there. So those of you who do not know me, I have been teaching for almost like a decade now, and many of my students entered IITs, they entered BITS, they entered NITs, all the top-notch institutes that you can probably think of, and many of them have got 2-digit All India ranks. So with that experience, I am here so that you guys get benefited from my teaching, and I enjoy teaching, I enjoy physics. I almost got full marks when I wrote my JEE, and let's kickstart the next chapter, and I hope you are all excited. So oh my god, Dinesh, you are a NEET aspirant. Well, if you want NEET PYQs, let me tell you, there are multiple ways. Number one is buy the Arihant NEET PYQ book. Second option is on Vedantu's platform itself, you get previous year NEET questions with their solutions and all of that. That's another option. But let me see if I can conduct a class, maybe not on this channel because this is JEE exclusive channel. So maybe sometime on VBiotonic. All right. Yes, definitely Dinesh, I'll consider the request. Maybe you should put this request to Vani ma'am. So once Vani ma'am invites me on VBiotonic, I'll definitely come over there. Okay. So anyways, for now, hit the subscribe button because all the next lectures will be available only if you hit the subscribe button and you do not want to miss this chance. And if you want the PYQs solution as well on our platform, if you want to solve more problems like the PYQs, and if you have any kind of backlogs which you think in your 12th standard you have not covered, or you need to revise your 11th standard syllabus, let me tell you that it's all there on our platform. The courses, the micro courses, the tests, the assignments, right at your fingertips. You can just download the Vedantu app. Also, there is a link in the description box below. You will get 50% flat off on all the courses that you are going to take, and this is the last day of the offer. This is the EdFest, the Children's Day EdFest, and the 50% offer is valid only till today. So today is the last day. So make sure you take the full benefit of this, and if you know someone, help them out, register to Vedantu. Alright, because you will see all the micro courses, PYQs, revisions, all of that is happening right now in Vedantu, and I'm pretty sure you don't want to miss that. Alright, so you will even find my micro courses. You can get enrolled for free of cost, because once you are in Vedantu, that's it. All the courses are free of cost for you. Hello Kupuswami, Murugan, welcome. Okay, chalo, let's get started. Well Dinesh, maybe yes, maybe not on this channel, but maybe on Biotonics someday. All right Dinesh, because we are JEE exclusive, anyways. So what is a wave and what is that we are going to talk about in this chapter? So and rather in this session. See, whenever some particle travels from one place to the other, so there is a particle which travels So this is a mass m with some velocity. Then it carries some energy. It carries some energy from that initial point to that final point, right? It started from some initial point, it went to the final point. It had some energy. It transports energy from one place to the other by actually carrying that energy and actually moving from one point to the other. But there is another way by which, without having any particle actually travel from A to B, you don't have to book your tickets, you don't have to actually travel from this point to this point, yet energy will travel from the initial point to the final point. Now, how do you make that energy travel from this initial point to final point? That is basically a wave. So in a wave, you will see that the particles might move, but they will come back to their original position. They might just oscillate, they might just shake, or maybe there are no particles themselves, like in the case of light. So, nothing actually goes from point A to point B, but energy moves from point A to point B. So it's just a way of transportation of energy. So there are two ways of transporting energy. One is particle, where the particle itself moves from initial to final point. Second is wave, where nothing actually travels from initial to final, but even if there are particles, they just shake around, they just oscillate, but the energy moves from the initial to the final point. And in order to transport energy, there are many ways, there are many examples. Take this example itself. This is the surface of water. You take a stick or a pen and you just hit the surface of water. You will see ripples of water flowing around. Haven't you tried this? Hi Nitesh, good evening. Hi Avnish, hi Rajat. Rajat will be completing the syllabus by January. Okay, don't worry, we are hardly few chapters remaining. Yeah, much before your JEE first attempt exam. So if you have thrown a stone, you see ripples of water being created which flows around. Those ripples are waves at the end of the day. That stone falling on that water is the disturbance, and that acts like the source of the disturbance, and the waves travel everywhere. I hope this is clear. Now, same way, even light can be produced, but before that, let me give you another example of a speaker. You obviously wear headphones or you have a speaker at your home. So what is a speaker? It is a source of a wave. What does it do? It creates disturbance, and that disturbance shakes the air molecules around it. And once the air molecules around it shake or oscillate or vibrate, they in turn affect the molecules beside them. And thus you will see the disturbance gets propagated in all the directions. And when these molecules in your air vibrate, your eardrum vibrates. And when your eardrum vibrates, you get the sensation of sound. I hope that makes sense. Thank you for all the love from Andhra and all over India and across the borders. Hi Ramya, thank you Yogesh so much. Thank you so much. So, same way light also works. When light is switched on, it's a source which creates disturbance. That disturbance propagates in all the directions, and eventually that disturbance reaches your eye, and that is essentially sensed by your eye. That's what happens. That's what a light wave is at the end of the day. And 300 years or more back, Huygens gave his theory of light. This is very important, crucial theory. It's there in JEE Mains, it's there in boards. You should also know it from JEE Advanced perspective. Okay, so what does his theory say? He said light is nothing but a wave, and the source of light is nothing but you create some disturbance in the medium, and once you create the disturbance propagates. And he said that light needs a medium which is called as ether, and it is there everywhere, even here, even in space, even under the ground, even in the ocean, in our atmosphere, even at a distant solar system. It's there everywhere. So light needs a medium to travel, and he named that medium as ether. But like we all know that in today's world, that it was eventually proved that light does not need medium to travel. It can travel even in vacuum, and there is no such medium which Huygens discovered, or he proposed rather, hundreds of years back. So this was just his theory. but nevertheless we study it because it has certain advantages. Somnath, I didn't miss Tamil Nadu. Whole of India covers Tamil Nadu, alright? So, yep. Thank you for all the love, bacha. Thank you. Alright. So, the entire assumption is that light is a mechanical wave for Huygens, and it needs that medium called as ether, and it is there everywhere, and it is assumed that this is transparent, so you cannot see it, you cannot feel it, but it is there, and this is what light makes use of to travel and to propagate its disturbance. So the moment you turn on a torch, the moment you turn on a candle, the disturbance propagates through this assumed medium by Huygens, which is called ether. And he assumed that light is a longitudinal mechanical wave, which is also wrong, let me tell you. Okay, light is a transverse wave. I hope you remember the difference between longitudinal and transverse. So when a wave goes here, if the particles oscillate this way, it is transverse, that is perpendicular. Whereas if the particles oscillate in the same direction, then that is longitudinal. Now, this theory actually helps us in a couple of things like explaining reflection, refraction, diffraction and interference. So that's the reason why we studied, although we know certain assumptions of this theory are not valid. The most important thing about this theory is it helps us predict what is the path taken by light. What is the way in which light will deviate, will turn around, will reflect back, and that is given by something called as Huygens Construction. And I'll tell you in a very simple manner what Huygens Construction is. Just imagine so many Pandus are standing in a line. This is one Pandu, this is one Pandu, this is one Pandu. Okay, there are many Pandus over here, they are standing in a line. Okay, now what happens is there is one new Pandu which comes over here, and what he does, he pushes this Pandu. He pushes this Pandu. All these Pandus are just standing over here folding their hands or just holding their hands like this. Okay, they're just standing. So now this Pandu number 1 pushes this Pandu number 2. Now what will happen is, there are n Pandus, let's say. When this Pandu pushes this Pandu will fall. That's it. He will fall on Pandu number 3. Pandu number 3, once he encounters that collision, when Pandu 2 falls on him, Pandu 3 will fall on Pandu 4. It's like dominoes. Are you able to visualize this? So this Pandu falls, this Pandu falls, this Pandu falls on this Pandu, he affects the next Pandu, and eventually this Pandu also falls. What has happened over here is this Pandu applied some force, there was some displacement, so he did some work, he created some disturbance. I hope you can see that. So there was some disturbance which was created. So this disturbance was created over here. That means this guy is the source, and there was flow of energy. There was flow of energy. That means that is nothing but a wave. And these Pandus are nothing but the medium, and this is the final destination where the energy reaches. This is exactly what happens in waves. You always have a source which disturbs the medium, and that disturbance affects the next one and the next one and the next one. The first Pandu can be called as the primary source. What will I call it? Primary source. Now, that primary source disturbed the second Pandu. That second Pandu is the secondary source because it is as if this Pandu disturbs the third Pandu. So the second Pandu is now the new source. I hope you visualize this. So as soon as Pandu 1 falls on Pandu 2 or disturbs Pandu 2, and Pandu 2 is now going to act like the new source, he is going to fall on Pandu 3. Pandu 3 will act like the new source because he is going to create a disturbance. Then Pandu 4 will act like a new source. So every time the disturbance propagates, you have new secondary sources. You have new secondary sources at different points in the medium. Are you able to understand it? I hope you understood this. Yes, this is very important. Dinesh, you should watch my waves lecture of 11th standard. It's there in the flash series. It will help you, okay? It's there. You cannot miss waves chapter and then study light waves. It is very dangerous. Yes, you should not do that. But nevertheless, I'll be teaching from basics. Don't worry, you'll understand most of it. Okay. Now, this is what, Huygens also said? He said that the locus of all the particles of a medium vibrating in the same phase is called as wavefront. That means, for example, I create a disturbance. This disturbance reaches here, here, here and here together. All these points, the disturbance reaches together. This is called as a wavefront. It's the locus of all the points which are in the same phase where the disturbance reaches together. The direction of propagation of light or any such wave is always perpendicular to the wavefront, which also makes sense because you can see that the rays of light, this is the ray of light, this is also a ray of light, this is also a ray of light, will always be perpendicular to the wavefront. Makes sense. Every point on that wavefront acts like a source of a new disturbance, which is just what I explained to you, and it produces new wavefronts which travel in all the directions, and they create new sources, and then they create new wavefronts, and then they create new sources, and this mechanism just keeps on, happening again and again. So all the points over here acts like sources. They also create waves in all the directions. They also create disturbance in all the directions, and what happens is there are new wavefronts created. New wavefronts created like this. I hope you can visualize that. What it says is the surface touching all the secondary wavefronts tangentially gives us the new wavefront. So you can see this is a new wavefront with this source. For this source, this is the new wavefront. For this source, this is the new wavefront. So the tangent drawn to all of them, that means this one. This will give me the new wavefront. See if this is understood. Somnath, I've been to Chennai many times. It's a lovely city. I've been to the beaches. I've had all the food. The podu idli, yep. The powder idli, gun powder and idli, yes. And the masala dosas, the sambar, chettinad masalas. I have been there and I've had all kinds of things. I have been to Ambur for Ambur biryani and all of that. Yes. So let's get moving. Now that you understand what Huygens construction is, let's make use of it for a peculiar construction, which is also called as Huygens construction. It's used to find out how the new wavefront looks like after some time. So say for example, somebody tells you, listen, this is my wavefront. Okay, this is my wavefront at some point of time. That means my rays are traveling like this, like this, like this. This is how my light is traveling in different directions. Okay, this is just for your visualization. Let me just draw it again. In order to find the new wavefront after certain time, what you should do? Look at this. Assume every point on this wavefront is a source. But which kind of source? Secondary source. So what are these? These are secondary sources. These are basically secondary sources. Very, very important. What will these secondary sources do? They will create new wavefronts in all the directions. So this source will create a wavefront here, this will create here, this will create here. So all of them are producing new wavefronts in all the directions. Now, if the light was traveling that way, then you draw the common tangent here, not here, because we have assumed that the light was traveling in this direction. I hope you remember I had just shown this was nothing but the ray of light. So draw the common tangent to all these wavefronts. So the common tangent will look like this. So this will give me the new wavefront. The wavefronts which are at the back, this common tangent should be ignored. So this one, ignore it. Okay, so that is very, very important. Now there is a flaw over here. Huygens did not explain why you should ignore the wavefront which is there behind. Okay, but yes, we know that the ray is traveling this way, light is traveling that way. So obviously the new wavefront should be formed ahead over there. Obviously not this way. I hope this is clear. Okay, is that understood? So this wavefront enables us to calculate the new position, the new location, the new look of that wavefront after some time. So if you had a wavefront like this, you will see multiple sources. What are they called? Secondary sources. What do secondary sources create? Secondary wavefronts. Now, when you draw the secondary wavefronts tangent, so that tangent gives you the new wavefront, the one which is there behind, ignore it. Okay, again after some more time you will get new wavefront and so on and so forth. Remember one thing, the distance or the size of this wavefront, okay, this secondary wavefront, this one, this size will be nothing but V into T. What is V and what is T? See, this point acted like a source. It created a wavefront which grew in size. So this point has created a wavefront which grew in size. So there was rays of light which was traveling in all the directions. So if you wait for time t, this radius that you see, this radius will be nothing but velocity of light, the velocity of light into the time that you wait for drawing the new wavefront. So speed into time gives you distance. So that distance is nothing but the radius of that circle. I hope this is clear. Yep. Dinesh, there will be numericals. Obviously physics will involve numericals. What is the point of having only theory, right? So physics is a beautiful blend of mathematics and the nature and the laws and so many other things to explain it. Yeah, correct. So now there are some positives and negatives. This is only from the CBSE point of view. So just go through your CBSE textbook for your boards. Please check out all the advantages and disadvantages and what are the things which Huygens couldn't explain. Mainly, Huygens assumed that the light is a mechanical wave, which is not true. Second thing, he thought that particle nature is not there with light, but later on we came to know that light has dual behavior. So that also he could not explain. Third thing, photoelectric effect, which is again based on particle theory, could not be explained via Huygens. But Huygens was successfully able to show reflection and refraction, something like this. Look at this, beautiful. Gautam, you're welcome, bacha, even if you're an NDA aspirant. So look at this, the wavefronts of light, they come from there, okay, they reflect from a surface, they reflect back from a surface. What is happening over here is, when these wavefronts reach here, all the points on this reflector, all the points on this mirror act like secondary sources. They act like secondary sources, and because it is a reflector, they do not create new wavefronts below, but in fact they create new wavefronts on the top. So that's why you will see new wavefronts being generated here, and these wavefronts go on to this side. You can see that. Observe this carefully. These wavefronts, as soon as they reach here, you will see new sources, secondary sources being formed here, and because the wavefronts reached here first and then they reach here, that's why this will be the secondary source first. This wave will reach later, so this will be the source later on. So this will start making new wavefronts. This will make the wavefronts later on, and that's why you will see the wavefronts go towards this side. You can see that the new wavefronts will be created here and they go towards this side. Is that making sense? Is that making sense to all of you? And finally, this angle and that angle will be equal, which can be shown very easily using geometry. Yep, very easily. Okay, clear? Yep. So what makes light waves differ from electromagnetic waves? Somnath, light waves is electromagnetic waves. Electromagnetic waves is not a mechanical wave. It does not need medium. It's a combination of electric and magnetic field. But this guy assumed that light disturbs some medium called as ether, which is obviously wrong. And electromagnetic waves, I just taught you in the previous class. Yep, I hope you remember day before yesterday. Now look at this. Refraction. This is light waves. Okay, it is meeting the interface of two different medium. Here the waves are traveling at one speed, here the waves are traveling at a different speed. You will see that the light has bent because the speed has changed. This is very interesting. This bending of light is nothing but refraction. You can see that. I'll show you one more example. Look at this. One more simulation to make you understand this. It's the same previous example, but on the side below, you have another medium. So some of the light which is incident gets reflected. Like when you hold a torch above a glass, some light gets reflected, some light passes through, correct? Same thing, some of the light got reflected, the light which got refracted, which went into the other medium is shown here. You can see the wavefronts of light start touching this interface one by one. The first point to be affected is here, the next point is here, next point is here, next point is here, next point is here. So this point will start creating wavefronts early, this point will start creating wavefronts little bit later, this will start creating even more later, and so on and so forth. But understand, the size of the wavefronts will not grow as fast as it was growing over here. Why? Because the speed of light is different. Okay, different medium, so different speed. So if the wavefronts were traveling at a certain speed in this medium, when these points on the interface start creating wavefronts, their sizes will be little bit different than the ones which were created here. So you will see the light rays have bent. You can see there is a slight bending. There is one more simulation to make you believe that. Look at this. New wavefronts created, new wavefronts created. This source was early, this was later, this was later, this was later. But you can see there is a slight bend because the manner in which they are growing is slightly different in this denser medium. It's slower because it is growing slowly. That's why the size of the new wavefronts are smaller, and that's why it bends. And that explains refraction. Vishal, my name is Capto Shreyas. It is in 11th class. Okay. Nandini, it depends. Some coaching institutes do it in 11th, some do it in 12th, but we are going to do it in 12th because yeah, that's how it is there in CBSE. Number 2, my 11th class timing is 7:30, 12th class is 5:30. Okay, great. Welcome Nikhil. Hi, Vanakam Zayed, welcome aboard. Okay, so this is the best way for you to see why light bends. Many of you question it. Sir, why does light bend? I did not understand it. Look at this. This is the correct explanation. What is happening to light? Why is it bending? In normal medium, you know, if there is a plane wavefront, it creates a new plane wavefront, plane wavefront. But the moment there is a medium, the wavefront bends. The reason is because the rate at which the wavefronts are created and the manner in which the wavefronts increase in size is slightly less. So you will see these circles are less, and that's why the wavefront bends, and that way the light also bends. Okay, very good. Yep. Now you can also prove it using geometry. Again, it's there in your NCERT. You can have a look at it. It's very easy. By simple geometry, you can prove Snell's law. Let's start solving some questions. Welcome aboard, Basit. Hi, Jayant. Seeing light lecture with light festival in Tamil Nadu. Oh, is it? What is the light festival called, Jayant? Okay, so Karthikeyan, there will be 3 sessions. One is this session today, where we are going to complete Huygens Principle, Sources of Light and Polarization. Next lecture, YDSC. Next we'll have diffraction. So I think 3 lectures will be good enough, and maybe one problem solving or advanced session after that. All right, cool. Okay, fine. Let's see how many of you can solve this question. Come on, my warriors. I hope, Anvesh, that also answers your question. Next session will be on YDSA, and tonight at 7:30 you will have 11th standard session. Okay, you are free to attend that, and tomorrow there is going to be, yes, a very special lecture, that's Squid Games. So if a spherical wavefront hits the plane mirror, then what will be the shape of the reflected wavefront after some time? Think about it. How will the reflected wavefront look like? Is it going to be this one, B, C, or D? Figure this out. Come on, my warriors. What do you think the answer should be? What do you think the answer should be? Is it going to be A? Is it going to be B? Think logically. Draw the rays, because you know wavefront is perpendicular to rays. So if you can predict the rays, you can definitely get this one as well. Come on. It's okay. You can be wrong. You can be correct. It doesn't matter. Just figure this out. Is it going to be A? Is it going to be B, or C, or D? Well, if you have answered A, B, or D, you are wrong. It is C, let me tell you that. And it's very easy to look at it. I'll tell you how. See, this is spherical wavefront which is falling on this plane mirror. So the rays of light are coming basically something like this. Correct? These are nothing but the rays of light. What happens after reflection? It will rebound with the same angle. Correct? So this ray will rebound like this, and this ray will rebound like this. Now if these reflect like this, remember the reflection angle is slightly different for each ray because the incident angle is different for each ray. So if you draw a perpendicular to all the rays, you will see this is your new wavefront. So I think the answer should be C. Correct Ramya, correct Karthikeyan. That's it. So the answer is C. Just draw the rays, you can clearly see it will be a curved line like this. None of them others will be correct. Let's see how will you fare in the next question. Light waves travel in vacuum along the y-axis. Which of the following may represent the wavefront? Okay, light is traveling along the y-axis. Only one of them represents the wavefront. Which one do you think it is? Figure this out. Only one of them, wavefront, and you know the ray of light. So try to visualize this. That will be much easier. So what's happening? Think carefully. You have the rays of light which are traveling in the y direction. So this is the y direction. This is how the rays are traveling. We all know this is the x-axis and this is the z-axis. So think about it. If rays are going like that, the wavefront is always perpendicular to the rays. So if I have to draw a wavefront, I think it will look something like this, isn't it? This is how the wavefronts will actually look like. This is the wavefronts of light. Yep. So these are nothing but the wavefronts. Yep. These are the wavefronts. And if you look at any of the wavefront, what is that one thing that you will see? You will see for any wavefront, the y coordinate, no matter if you stand here, or here, is nothing but constant. So that's the equation of that plane, and hence what should be the correct answer? Come on, my warriors. Yes, bacha, I'm in pro. You can find a lot of my courses in the pro subscription, definitely. Oh yes, Dinesh, why not? And it is called as Karthigai Deepam. Wow, nice name. And I am so glad that luckily we chose this day to start this chapter. Okay, so is that fine? So y is a constant. Moving on to the next question coming up on your screen, and here it is. Yes, option A was correct. So, option B was correct. Plane wavefronts are incident on a spherical mirror as shown in the figure below. Qualitatively sketch, that means you have to guess how will it approximately look like just after it gets reflected. So these wavefronts go hit the concave mirror after the reflection. Which of the following do you think will be the correct way of representing it? So Jayant, wavefront is nothing but perpendicular to the rays, number one. Wavefront are all those points where the rays reach simultaneously. So if you have a source, it will emit rays in all the directions. You will see a surface where all the rays reach simultaneously. After some time, there is a new wavefront because all the rays will reach somewhere else, and that surface will be the new wavefront. So that's a wavefront, Jayant. Okay, and you can watch in detail because Huygens Principle is very important, which talks about how to construct new wavefronts and the theory of light. So what do you think the answer should be? The plane wavefronts go here. What will happen to the light after reflection? If you are ever confused, okay, just draw the rays of light. That will remove all ambiguity. If you draw a perpendicular, that will give you the incident light, because the perpendicular to the wavefront gives you the rays of light. So basically what you have is parallel beam of light, and this parallel beam of light when incident on a concave mirror. What is a concave mirror? Is it converging mirror or diverging mirror? Think about it. Concave mirror is nothing but a converging mirror. Correct. So if it is a converging mirror, all the rays will meet somewhere like this towards the focus. Isn't that right? So they will reflect and they will meet like this. That means if at all you draw a perpendicular to those rays, you will get the new wavefront. So the new wavefronts look like this. And I think only option C is correct. I hope that makes sense. Yep, it is converging. So option C, you can see the wavefronts look like this. So these are the wavefronts, after the light comes over here and reflects and meets at the focus. So that's the answer, option C. Correcto. Beautiful. Yes, Sai Varshita, like I said, I am in pro subscription. You will find my pro courses like, HC Verma discussion course for 12th standard, even for 11th standard derivation courses. Then you'll also find my numerical problem solving course for 12th and even for 11th standard. Yes, definitely. Okay, chalo. So yeah, that was the solution, but that you will get it in the PDF when you join our Telegram channel link. So don't forget to join the Telegram channel, because all the important updates, all the important notifications and any other information, the PDFs, solutions, etc. always are posted on our Telegram channel. Okay, so what do you think is the correct answer for this question? You have a wavefront P which passes through two objects, two systems. We do not know. It could be lens, it could be mirror, it could be prism, I don't know. And it emerges finally over here. First, after passing through A, it becomes Q. After passing through B, it becomes R. So the question is, what do you think the system A and B are? Sai Varshita, I'll tell you, it's very simple. Just search for my courses, or do one thing, after the video ends now, just leave a comment. I'll tell you what exactly to search. Okay, I have to respond to many comments of yesterday's and today's class also. So just post a comment. I'll respond on what exactly you should search to get into my micro courses. Okay. All right. Oh my God. You want me to speak in Tamil for 2 minutes? Okay, Dinesh, I'll come prepared then for my next coffee session. But tomorrow we are going to have Squid Games, okay? Soon you'll have a coffee session also. Don't worry. So, okay, some of you are saying D. All right, let's start by drawing it. Drawing the rays basically. When you draw the rays, it becomes very easy to understand. See, these rays are still curved. See, if it was a concave lens, then the rays which are coming like this, probably, because concave lens is diverging in nature, the rays would have gone like that, right? But if you have a converging lens as in like this one, so if the rays are like this, then they converge even sooner. So I feel it should be converging for sure, because these rays which are going like this, they go like that. So these rays which are going like this, they go like that. So that is definitely a converging lens. After this, what is happening? See this? These rays, okay, these rays get diverted here. Okay, these rays, if let's say for example there was a ray here, it gets diverted. So when will this deviation happen? We all know this happens in case of a prism. When you have a prism and you pass any light, what happens? The light bends, it deviates. It was supposed to go here, but it deviates. So definitely this is a prism, but this prism is ulta. So this prism is like this. So that's the reason why the rays which are coming like that, it will bend like that. So this is a prism, that is a converging lens. Hence, that's the answer. I hope that makes sense, all my warriors. Yeah, so converging lens and a prism. So these are the kind of questions one can expect. Okay, one can expect in Huygens principle. Let's get moving to the next one. Okay, but before that, let me tell you, right now there is Vedantu's mega scholarship admission test for 2021, and this test is going to give you amazing scholarship when you want to join Vedantu's courses. And not just that, there are lots and lots of exciting prizes to be won. Like, I'll tell you, first of all, this registration is free and it will also test your concepts. So for the heck of it, you can give it. Who knows? You might win some prize, you might win some consolation prizes. It is online and it is applicable for all students right from 4th standard to the dropper student. And there is a pool of 100 crores from which the scholarship will be given. So what and all you can win? If you are rank 1, you can win Apple iPad, the latest one. You can win a Kindle from till 5th rank. You can get AirPods from till 10th rank, and Vedantu bags till 50th rank. And beyond that, you obviously get your Vedantu scholarship as well. So guess what? This test you will be able to attempt it on every Wednesday 8 p.m. Keep this in mind, every Wednesday 8 p.m. Okay, starting 17 November, that's just the last Wednesday, till 22nd December. All you have to do is go to VMSAT website, that is this one, vmsat.vedantu.com, enter your credentials. It's very simple. So when you go to vmsat.com, you can choose your grade, name, enter your details, and that's it. Log in, and this test will be for free of cost. So you get assured scholarships, you might have a chance to win some prizes, and it also will test your concepts. So go ahead, check it out. Wow, Gautam, you got 20%. Interesting. That's really cool. Very good. Okay, Zayed, welcoming me in all the possible languages and ways. Thank you so much. Is 100% scholarship possible? Yes, Dhanush. If you get really good marks, why not? So all things are possible, you know. And you can also sell your iPad and win more money, unless you want to use it. Okay. Thank you, PL, so much. Okay, let's move to the next part. The types of wavefronts. See, what is wavefront? Wavefront is nothing but the locus of all the points where the light reaches simultaneously. Now, the wavefront's shape and size depends on the source itself. How is the source? The source decides how the wavefronts look like. And as you go far away, the intensity may change. And that intensity depends on one thing, and that is nothing but the amplitude and also the distance. So this is very, very important for you to remember. Intensity is dependent on the square of the amplitude. Every time, even in the last lecture, I had given you the formula in electromagnetic waves. If you remember it correctly, intensity had electric field amplitude square. Do you remember that? And I told you this same thing over there as well. Intensity was directly proportional to the square of the electric field amplitude. So this is always true, even in sound waves, even in transverse waves, even in light waves. Any wave intensity is directly proportional to the square of the amplitude. Yeah. Okay. Now, based on the type of sources, we have three types of wavefronts which you need to know for JEE. The first one looks very crazy. Hi Rihan. Hi Riha. Okay, is your name Riha or Rihan? Welcome aboard. Okay. Jayavant is already hypnotized. Jayavant, you will get more hypnotized looking at these simulations. Look at this. This is spherical wavefront. So there is a disturbance, and what it does is it creates spherical wavefronts. This source is a point source or a spherical source. So the surface of a sphere oscillates. That in turn disturbs the medium around it. Those wavefronts which are formed, like you can see, are concentric shells, concentric spheres of growing size. Can you see that? These shells are growing in size. So these are spherical wavefronts. Very good. Okay, welcome Rihan. Now, as you can see, whatever energy is there, that energy is spreading on a bigger surface. Can you see that? Right now, there is some energy with light that's on a small wavefront. As it goes far away, as it becomes big, the energy is now on a bigger surface. So, what happens is, as these wavefronts go far away, the intensity of the light will drop because the same energy is now on a bigger surface. And if you remember correctly, what was intensity? It was energy per unit area per unit time. So, if the energy is now on a bigger area, so there is, understand, less energy per unit area. So hence the distribution becomes less and the intensity of the light becomes less. So if you are ever wondered why the bulb appears very bright when I am close and it appears faint when you are far away, the reason for that is basically this. The intensity of the light will go down. So essentially what happens over here is, if this source of light has a power P. So what is this P? This is the power of the source. And let's say you are at certain distance. You are at a certain distance R. Then for this particular shell whose radius is R, the intensity, which is nothing but energy per unit time. Okay, energy per unit time per unit area. This energy which is coming per unit time is nothing but the power of the source. So this is nothing but the power of the source upon the area. That area will be nothing but 4 pi r square. So you can see that the intensity is inversely proportional to r square. Is that clear? So 4 pi r square is the surface area of that shell. So that energy per unit time is now spread across that spherical area. Welcome aboard. Yay! Welcome my minion. Welcome aboard. Welcome aboard. Is that clear, my warriors? Let me know. This is a very, very important slide. Please make note of it because you need to visualize how a spherical wavefront actually looks like. Only when you can visualize it, then can you actually think about why intensity is power by 4 pi r square. Moving on to the next one. Okay, so this is very important slide. Again, it will be given to you in the PDF. So a spherical wavefront is created by a point source and the wavefronts look concentric shells and the intensity is inversely proportional to r square. Keep this in mind. Second is the cylindrical wavefront. Yeah, cylindrical wavefront means what? I'll give the best example. I have a best example over here. Let me show this to you. It's a very interesting thing. Guess what? So I have it. This is a cylindrical source creating cylindrical wavefronts. So this speaker of JBL, okay, I'm not promoting JBL, but whatever. So this JBL speaker, it looks very cool though. Let me see. Oh, does it have battery? Yes, it has battery. Wow, beautiful. So this source over here is a cylindrical because it creates disturbances in all the directions and those disturbances grow in size radially like a cylinder growing not in height but in radius. So when you turn on the speaker and it creates sound, it creates wavefronts in all the directions which grow in size like this. Isn't that cool? Yep. So that's what a cylindrical wavefront is. Okay, let's just turn this off. Now, in this situation, in this particular situation, what will happen is if this is the power of that source, which is like a linear source creating cylindrical wavefronts, for some distance r, and let's say the height of the source, okay, the height of the source was h, so this was the height of that linear source, then the energy is distributed on the surface area of the cylinder, the curved surface. So the intensity over here, because it's now distributed on a larger area, will be power divided by that area. That area is 2 pi r into h. So the numerator always will have energy per unit time which is flowing, and this is the curved surface area, the curved surface of a cylinder is the curved surface area of a cylinder. Okay, I hope that makes sense. So Ansh, stay with me, watch me solve problems, you'll get a hang of solving the problems. So if you are not having that knack of solving problems, you should watch teachers how they solve. Look at solved examples, then solve very easy questions, then go to medium, then go to difficult, then go to JEE mains, then go to even more difficult questions, and then go to JEE advanced previous year questions. So that's the logic which you have to go ahead with. Ram Kailash, yes, one cool stuff. How many gadgets are there in my house? Maybe you'll have to wait till the last lecture and find it out. And maybe there will be still more, and I'll keep coming up with new gadgets every now and then. So this intensity now you can see is inversely proportional to r square. Nahi, it is just r. Okay, very, very important. It's just inversely proportional to r. For spherical, it was 1 by r square. So let's see the final outcome. For a cylindrical source, you know, for a linear source or a cylindrical source, the wavefronts are also cylindrical and they look like this, like expanding cylinders, and the intensity is inversely proportional to r. The last one is planar source. If you're very far, okay, then those curved wavefronts will almost become flat. Think about it. A curved wavefront, as it expands, it becomes almost like flat. Or maybe, let me show you the next gadget. Look at this. This is my studio light. Oh my god. Look at this. Hey guys, my next gadget. Yes, my minion. Yes, Ram Kailash. I hope you're excited now. Okay. Yeah. Okay. Yeah, Somnath. My energy is always the same. This is a planar wavefront. Do you see that? Yeah, beautiful, right? This is a plane source creating plane wavefronts of light. So this is nothing but a planar wavefront. Yep, this is a planar wavefront. Okay, let me just keep this. So by the way, Any idea how many of these are there right now in my room and how many of them are on? Yep. So type in, what do you think? Hi Worship, welcome aboard. How many of these are there in my room and how many of these are on? Okay, so that's a planar wavefront, and guess what? If that's the power of that source, okay, if the power of the source is P, then the energy remains on the same area. So the area remains the same, hence the intensity remains constant because the energy does not distribute itself. 5 lights, oh my god, Parmenian has got it right, but actually there are 4 lights like that. The 5th light is this one. This is the 5th light. Okay, so this is the 5th light. So yeah, technically I have 5 lights, but the 4 lights are the planar sources, and this is the ring light that you have over here. Okay, cool. So what do we have over here? So when you have a plane source, it creates plane wavefronts, and these plane wavefronts do not grow in size, so their area remains the same, the distribution remains the same, the intensity remains constant. That's what it is. Okay, let's start solving some questions, and here it is, the first question on your screen. A cylindrical wavefront which is spreading out from a line source, maybe like a narrow slit, so like a cylindrical source creating wavefronts. When the wavefront is at some distance r, then the amplitude is proportional to r raised to m. What is the value of m? Think about it. What do you think is the value of m? R is the distance from that source. Think what is the formula for cylindrical source and how should amplitude change with it. So whenever you have a cylindrical source, so when you have a cylindrical source, obviously it will create cylindrical wavefronts around it. Okay, it creates cylindrical wavefronts around it, something like this, and at some distance r, the intensity was proportional to 1 by r. I hope you remember that. Intensity was proportional to 1 by r for a cylindrical source. And also I told you intensity is proportional to the square of the amplitude. That means the square of the amplitude is proportional to, therefore square of the amplitude is proportional to 1 by r. Because if this is proportional to this and the same thing is also proportional to this, so these two are also proportional. So amplitude square is also proportional to 1 by r. So amplitude is proportional to 1 by r's root, which is nothing but, what is 1 by root r? R raised to minus half. So hence, what is that power m that we are talking about? It is nothing but B option, which is minus half. Correcto. I hope that is clear. Let's move on to the next question. Okay, perfecto. Moving on. So there is a point source which emits light waves with an average power output of 80 watts. It emits, light waves with an average power output of 80 watts. So the question is, find the intensity 3 meters from the source and also find the distance at which the intensity becomes 10 to the power minus 8 watt per meter square. Very interesting question. So read the question carefully. So the power of the source is given and you have to find what is the intensity at certain distance and where is the intensity this much. So let's just try to visualize it. Here I have my point source. Here I have my point source. Okay, and it has a power of 80 watts. It's an 80 watt power source and it creates waves which are again spherical in nature. So it will be something like this. These are the spherical wavefronts which will be created by it. And the first question is, when you are at a distance of 3 meters, so at a distance of 3 meters, what is the intensity of light? Use your straightforward formulas, you will get the answer. The intensity is power divided by the surface area, which is 4 pi r square. So power is nothing but 80, 4 into pi into r. R is 3, so 3 square. 80 by 4 is 20, 3 square is 9, so 20 by 9 pi. So that would be the intensity. So that's the first answer. The answer will be having the units watts per meter square. Energy per unit time, that's watts. Per unit area, that's meter square. Good evening Shivji. Hi Durga Prasad, welcome. Okay, next up, The second question says, where is the intensity this much? So again use the same formula. So there will be certain other distance r where the intensity will be this much. So substitute the intensity as 10 to the power minus 8. Power is still 80 by 4 pi. I do not know that distance. So r square comes here. 80 by 4 pi remains as it is. 10 to the power minus 8 comes below. 80 by 4 is 20 and this is pi, and when it goes on the top it will become 10 to the power 8. So that's r square. So r will become root of 20 by pi into 10 to the power 4 meters. So that is the second answer. That's it. So you check whether it is given in decimal, whether it is given in values, whether it is given in these kind of pi based relations. So accordingly you can calculate and give the final answer. So if we can calculate it in decimals, it comes out to be 0.71 watt per meter square, and the distance comes out to be 25.2 kilometers. Crazy. If you go 25 kilometers, that's when the intensity will come down to this small value. So that's a large distance, but still it is there. You can still see the light, it will be very faint. Hi Gongutla Rajni, welcome aboard. Are you ready for the last part of today's session? And then, the first session is over on light waves, and then maybe we'll have the other sessions of light waves as well. Okay, so let's go ahead. Come on guys, show some josh and be ready for the next part, polarization. There were so many questions, again and again on this topic. So that's why we are doing it. Many institutes even skip this topic. Okay, I don't know why. Last lecture of 12th standard, the Pathfinder series, I have told you light is an electromagnetic wave. And it has two planes in which electric field and magnetic field oscillate. We, for convenience, take the electric field as our plane of primary oscillation. So, actually speaking, light is a transverse wave. It's not a longitudinal wave, light is a transverse wave. And all transverse waves show this peculiar behavior of polarization. And what is polarization, you will understand in a bit. But for now, understand a transverse wave has a plane in which it oscillates. We choose electric field as the plane of oscillation. That's very important. And the thing is, the normal light which is there around you is actually not polarized. It is basically unpolarized. What do I mean by that? See, in this situation, you can clearly see that the plane in which the electric field oscillates is basically this one. So there is a single plane of oscillation. So hence this light is just called as polarized light. This is polarized, that means there is only one plane in which there is oscillation of the electric field. If you look at it from behind, if one were to look at it from behind, okay, something like this, what he would see is the light's electric field goes up and down like this. So this arrow mark shows that the light is basically polarized. So this is how the electric field oscillates up and down. So this polarized light, oscillations look just like this. Is that clear, my warriors? Is that clear, my warriors? Okay. So if you look at it from behind, you can clearly see there's only one plane in which the light waves oscillate, the electric field oscillates. But in reality, your regular light is not polarized. There are random planes in which it oscillates. Sometimes this way, sometimes this way, sometimes this way, sometimes this way. So many planes are there in which it oscillates. So if one were to see such a kind of light, you will notice that once the light is oscillating like this, then it is oscillating like this, then it is oscillating like this, then it is oscillating maybe like this, then it is oscillating like this. So all possible ways. This is basically unpolarized light. So there are different planes in which the electric field, will oscillate. So there could be different planes. So I can just probably show you something like this. So this is one plane, this is going to be another plane, maybe like this. Okay, so you can visualize this. So there are so many planes in which the electric field oscillates. That's what happens in reality. But there are ways to convert unpolarized light into polarized light. There are ways, or rather there are advantages and certain uses of polarized light as well. So unpolarized light, which is your ordinary light, which comes from the sun or the bulb or the candle, that's unpolarized in nature. The electric field vectors are in all possible directions. Okay, great Somnath, great Shivji, very good. Now let's talk about how do you exactly polarize light. Okay, and before that, let me also give you the definitions. These are very simple and important definitions. When I say that the light is polarized, it means that the plane of oscillation is only in one single plane. This is very important. You can clearly see polarized light means, like I said, limiting the vibration of the field only in one direction. That is polarized. When it is in multiple directions, it is unpolarized. The plane in which it oscillates, I just told you, it is called as the plane of oscillation. That's the second definition you should know. And the light can be polarized by making the unpolarized light passing through crystals and passing through certain mediums. So if you have unpolarized light, you make it pass through certain crystals or certain medium, you will see immediately after that, when it comes out, it becomes polarized. So the light rays, can be polarized by certain medium, by certain crystals, by certain stones. Yep. So those are called as Polaroids. So, or polarizers. They basically, restrict the plane of oscillation only in one direction. They do not allow electric fields in other direction to transmit beyond them. So they restrict the electric field, and that's why they are called as polarizers or Polaroids. Okay. Now you should know how to represent polarized or unpolarized light. Yep. So if let's say the plane of oscillation is like this in the plane of the board, you can show it like that. Those lines, they show that the electric field is in this plane. It oscillates like this. If it goes like that, then it is shown dots. And if it is unpolarized, then you show arrow marks everywhere. So this is basically unpolarized light. So this is just the way in which you represent light, whether it is polarized or unpolarized, and in what direction. Let's talk about Polaroids. Hi Darshan, yo Zayat, hello RP Sharma, hello Rishabh, good evening Bachalo. Let's move on. Polaroids, like I said, they restrict the vibrations in certain directions. They only allow certain electric fields to pass through them. It's like a traffic signal. It's like a nozzle. It's like a wall which does not allow certain things, but it only allows oscillations in a particular plane. And the best way to see that is this particular simulation. Look at this khichdi. Look at this DNA, RNA, I don't know what. Yellow, blue, red, green. So many different planes. This polarizer has, or rather I am calling this as vertical polarizer, because it only allows vertical electric fields. All those fields which are in the vertical plane are allowed, all the other fields are just restricted. Very interesting. This is khichdi. Yes, we are all friends, we know each other, Somnath. Yep. So this, I hope this makes sense. And this can only happen in transverse wave. This will not happen in longitudinal waves. So this light wave, which is unpolarized, becomes polarized, okay, after passing through a polarizer. Okay, the plane in which the polarizer polarizes it, it's called as the plane of polarization. The plane in which the light gets polarized due to the polarizer is called as the plane of polarization. If I tilt this polarizer, this blue line which is coming out will also be tilted, because those components only in that plane will be allowed. So if I could magically tilt it, you will see other components will come outside it. Okay, so it depends on how it allows, in which plane it allows. So the orientation of the polarizer matters. Look at this. This is very important. Very important. When you pass unpolarized light through a polarizer, okay, then you will see that the light gets polarized. Yes, the light gets polarized. And the interesting part over here is that if the intensity of the light was I, okay, this is the intensity of the light, of unpolarized light, then after it comes out, exactly half of the light enters in. Because think about it, each polarization plane, has two components, y component, x component, y component, x component. This polarizer completely obstructs one of the components and completely allows the other component. There are two components, one is x component, one is y component. Each of these planes of oscillations have two components. One of them gets cut off, only one of them comes out. Hence, the intensity of the light which comes out of this polarizer is basically I by 2. Very, very important formula that you must know. So when the light comes out, which is unpolarized light, when it comes out of the polarizer, it becomes polarized and the intensity becomes exactly half, because half of the components are just gone away. Okay, so that's very, very important. You can analyze which one is there on the other side. Okay, this is called as an analyzer, but that's later on. We'll see that later on. Yes, this is in wave optics. Now, what is analyzer? Analyzer is also basically nothing but a polarizer. But observe this. Observe this. This polarizer right now has a transmission plane like this. So only these components will come out over here. Does it make sense? Only the components which are vertical come out over here. Imagine another polarizer whose transmission axis is perpendicular. So the plane of oscillation of this light is this way, but the transmission axis, the plane which gets transmitted is perpendicular. Nothing will come out. No light will come out over here. So if you hold a screen, you will not see anything over there because the light is polarized vertically, but the transmission axis is perpendicular. Nothing will come out. Nothing will come out. But if you rotate it, then you will see that the light which comes out will have certain value. And let's see what is that value. Observe this. Very, very important. If the intensity of the light which is polarized is I naught and the plane of oscillation is like this, plane of transmission, can you see that? The plane of transmission makes an angle theta with your plane of oscillation, then the light which comes out over here is basically I naught, the original intensity, into cos square theta. Very, very important. Very, very important. You can look at it this way. Only if the amplitude was A naught here, when it goes through it, the new amplitude that will go, only this component will pass. Remember, the other component will not pass. So only the cos component will pass. So the amplitude which will come out will be A cos theta. And we all know intensity is square proportional to amplitude. That's why if intensity was I naught, the intensity which will come out will be I naught cos square theta. Is that making sense? So if the amplitude becomes A naught cos theta, intensity which was I naught after reaching there will become I naught cos square theta. Very, very important rule. This is called as Malu's law. What is this called? This is called as Malu's law. Very interesting law. So it just tells you if two polarides, are at an angle, or the plane of oscillation makes some angle with the transmission axis, how much intensity will go on to the other side. That's it. Okay, very, very important. I naught cos square theta. Cool. We are going to solve some problems, but before that, no ABCD. It is not recorded, bacha. Somnath, I think I told this before, how many classes I'm going to take. Yeah, I think I just told this before. Yeah. Cool. Brewster's law. Look at this. If you have unpolarized light and it falls onto a denser medium, unpolarized light, okay, which has planes of oscillations in multiple directions, if it falls on some medium, two things are going to happen. One will be refracted, that means it will go into the denser medium. A part of it will be reflected. If you make that light fall, at a certain angle, you will see that the light which is reflected will be polarized. And that angle at which you make that light fall so that the reflected light is polarized is called as Brewster's angle. Brewster's angle, very important. ABCD, concentrate on the lecture, don't worry about other things. All right, cool. So now what happens if the angle of incidence is something else apart from the Brewster's angle? Then you will see that the light which comes out will be still polarized, but not so much. There will be some teeny components in the other planes. So the light gets completely polarized at Brewster's angle, but for other angles the light is not so heavily polarized. That's what it is. That's Brewster's law. And that angle at which you should incident that unpolarized light, so that once it gets reflected you will see it is polarized, is called as Brewster's angle. And there is a very simple formula for that. So tan of theta is basically refractive index. This theta is your critical angle or Brewster's angle. Okay, Brewster's angle for which the light gets completely polarized. Remember this, very important law. Okay, mu is equal to tan theta. Let's solve some questions so that you get a hang of it. So what and all we have learned today in polarizers? We have seen that in a polarizer is nothing but a device which restricts different planes and it allows only a certain plane of oscillation. And if unpolarized light comes out, the intensity becomes first half. And then when that light passes through another polarizer, then only I naught cos square theta intensity will come out of it. Brewster's law is when unpolarized light falls on a medium, the reflected light becomes polarized at a specific angle which is called as the Brewster's angle. Okay, let's solve the question. Hi Anusha, good evening. Hi Jesus child, welcome aboard. So what do we have? A Polaroid is placed at 45 degrees to incoming light of intensity I naught. Okay, so there is a Polaroid placed at 45 degrees at an incoming light of intensity I naught. Now the intensity of the light passing through the Polaroid after the polarization would be, this is very easy, you can get this. To make you visualize what's happening, see, so you have a Polaroid which is placed at 45 degrees to an incoming light of intensity I naught. So this light has intensity I naught and you have, you know, a Polaroid something like this, and that is making basically an angle of 45 degrees. Now the intensity of the light passing through the Polaroid after the polarization would be, so obviously the light which will come out will be of slightly lesser intensity, and that intensity will be I naught cos square 45, and cos 45 is nothing but 1 by root 2, so 1 by root 2 square, which is 1 by 2. That means the answer will be option B, done. Correct Kshitij, correcto. Will this be useful for 11th standard? Well, it's too early for 11th, but yes, you can study this, no harm, because there is a waves chapter in 11th also, but you know, it's preferably better understood when you have already studied waves in 11th, mechanical waves, that is sound and string waves, and then you move on to light waves. But nevertheless, yes, you can watch it. Okay, so option B is correct. Moving on to the next question. This is also a beautiful question. Let's see how many of you can do this. Unpolarized light of 32 watts per meter square, there was watts per meter square, okay, ignore that, passes through 3 polarizers. The first and the second make 30 degrees and the last one is crossed with the first one. Okay, so let's try to draw this first. So we have 3 polarizers. The first polarizer, okay, the first polarizer is something like this, and the second polarizer makes an angle 30 degrees with the first one. So the second polarizer makes an angle 30 degrees. So this is basically 30 degrees. This is your first one, this is your second one, and the last polarizer is crossed with the first. Crossed means perpendicular. Cross means perpendicular. So if first is vertical, the last one is basically, horizontal. This is the third polarizer. So you can see that this is basically 90 degrees. Now unpolarized light enters. This is unpolarized light. So let me show unpolarized light like this. This is how you show unpolarized light. This is unpolarized. What is the intensity? 32. Great. What happens when unpolarized light enters into a polarizer? Obviously it gets polarized. So you will see the light will be polarized and the intensity will become exactly half. So it will become 32 by 2, which is nothing but 16. Exactly half. Remember, half of these will enter, half of them will just go away. Now when it goes through the second polarizer, but that is at an angle, so only a component of it will go. So only a component of it will go. So how much component will go? Because this angle is 30 degrees and initially it was going vertical. Now only the cos 30 component will go, amplitude wise, intensity wise cos square. So it will be nothing but 16 cos square 30. Cos 30, how much is cos 30? Cos 30 is root 3 by 2. So square will be 3 by 4. So it will be nothing but 4 into 3, correct? Because this 4 and this 4, yep. So 4 into 3, which is nothing but 12. That is what it will be over here. Now this light is going to make, think about it, 60 degrees with this polarizer. Because it has already turned by 30 degrees. Now it is making how much? 60 degrees with the next polarizer. So the final intensity of this light which will come out over here will be 12 cos square 60. I hope this is clear. I hope this is clear. Yeah. So what is cos 30? Cos 60. Cos 60 is nothing but half. So half square means 4. So 4 goes. So you will be just left with 3. Hence the answer should be 3, which is option B, and done. What an interesting question. Clear, Arnold? Very good. Oh my God, is it really? Happy Men's Day? Okay, Happy Men's Day. Cool. Technically you guys are boys, not yet men. I think you'll have to wait for a year or so. But yes, nevertheless. Okay. So the answer is 3. Beautiful question. Unpolarized to polarized, light intensity becomes half. The first time it is turned by 30, cos square component of 16 will go. Next time it is turned by 60, the cos square 60 component will go. So the idea was to draw the diagrams and then proceed ahead with caution. So beautiful. Option B is correct. Moving on to the next one coming up on your screen. When the angle of incidence on a material is 60 degree, the reflected light is completely polarized and the velocity of the refracted ray inside the material is how much? 2 chapters combined together. Let me tell you what is happening. See, you have a medium. Let me just drop a perpendicular over here. And what you have is unpolarized light. So this is unpolarized light. That means the plane of oscillation is in all possible directions. This light, when it falls at a certain angle, okay, obviously part of it will get reflected, part of it will get reflected, and a part of it will get refracted. Okay. It is given that the one which is reflected is completely polarized. Read the question. It is completely polarized, the one which is reflected. So if this is completely polarized, it just means one thing. This angle over here is nothing but the Brewster's angle, which I just told you. Brewster's angle, only at that angle is the light completely, polarized, the one which is reflected. So let's see, tan of I will be nothing but refractive index. I is nothing but 60. This is Brewster's law, by the way. So tan of 60. So tan 60 will be mu. Tan 60 is nothing but root 3. So mu is nothing but root 3. Interesting. But that is not our question. The question is, what is the speed of the light which is refracted? That means inside. And all you need to do is use Snell's law. What is Snell's law? The speed of light in the first medium, which is, let's say, C, upon speed of light in the actual medium, which is water, liquid, whatever, is nothing but the refractive index. That's what Snell's law is all about. So let's do this. What is C naught? Speed of light in vacuum, which is 3 into 10 to the power 8. Speed of light in that liquid, I do not know. Refractive index is just root 3. So the whole idea was to find refractive index using Brewster's law. Then it becomes simple. So speed of light, this root 3 cancels, it will become root 3 into 10 to the power 8. Is that option there somewhere? I think so. It is option C. Hence, that is done, done. Is it clear, my warriors? What a beautiful question. So, yep, I have certain questions for you guys as homework. So this lamp, which is at 30, which moved to 90, what do you think will happen to the intensity? Put up the answers in the comment section. The second question is this one. This beam of natural light which falls on 6 polarizers. Interesting question on polarization. What will be the final percentage of light that will pass through it? Very interesting question. Post it up in the comment section. Now let me tell you, if you are interested in doing revision of term 1 syllabus, problem solving, you want numericals, you want test papers, you want assignments in English medium, you want my micro courses, you want amazing teachers like me, you want test series with report cards, live classes, recordings of so many micro courses, then Vedantu is the right place to be. First of all, remember, Vedantu this year produced 1500 plus selections in JEE Advanced. There are almost 6% of the students who will enter IITs will be from Vedantu, and many of these students are from smaller towns and cities where quality education is not possible. And this just says that no matter where you are, you can crack JEE right from wherever you are sitting at home. You don't have to travel to big cities, big towns or big coaching centers, and that's what Vedantu has shown year again. So if you are interested, I would say consider this offer, because today is the last day of EdFest, the Children's Day Festival, and you will get 50% off on all the courses that you are joining. Be it the KVPY course, be it the crash courses, be it your regular pro courses, it's all there, NDA course, everything. All you need to do is go to the description box right over here and just go down. You can see class 12th Vedantu Pro. There is dropper batch, CBSE term 1, term 2 syllabus based courses. If you want to change the course, you can just change it here. You can see all the details are over here. There are 3 packages, Light, Classic and Plus. Light gives you everything, but if you want doubt solving on the mobile app, then you go for the Classic. And when you go for the Plus, you get a personal guide, a teacher to mentor you. Most of our students go for Classic, and some special needs students who need that extra care and attention go for the Plus version as well. So I would say, even if you want to try out Light, go ahead, because it's hardly 38,000 for the next entire year. I mean, and you have also EMI options available. You can also try it for 15 days for 850 rupees. It's nothing. Use my coupon code SHHPRO. Even for the classic version, Plus version, it's hardly 1,100 rupees. Try it out. If you don't like it, it's okay. Then just don't renew your subscription. That's it. But at least try it out, because today is the last day. Tomorrow onwards, these prices will become in couple of thousands. So that's the reason why I'm asking you to try it out today. And if you enjoyed my class, you know what to do. First of all, recommend this channel to all your friends, cousins, your school mates and classmates. And yes, you yourself, first of all, hit the subscribe button. And yes, as a small token of Guru Dakshina, you know what to do. Go hit the like button as well. Yes. Thank you, Somnath. Take care. Am I late to register for Pro? Late, but not too late, Shiv Kumar. There are lots of courses still which you can get yourself enrolled into. There are batches which have just started now. So this Monday only, please get yourself enrolled now. You can watch my micro courses, you can watch my courses, my problem solving, get yourself enrolled into term 1 syllabus completion portions, everything. It's all for free once you are in the Pro subscription. Try it out for 15 days. You have already delayed 15 days, nothing more will change. So in fact, you might see something better and that might change your mind. So I would hopefully see all of you in the Pro subscription. Tejas, I'll definitely consider that. I have to change my batch to Enthuse batch. I have taken Pro subscription because, so there is nothing like Enthuse batch, Shai Varshita. If you have any problem, do one thing, just, either put up a comment after the video or send me a personal message on my Instagram handle. If there is anything else that I can do, I'll definitely do it, because I'm leading the physics department. I will definitely take care of it. Okay? Chalo. Thank you very much, and hope to see you soon again tomorrow in Squid Games, and then on Monday as well in the remaining sessions. Bye bye. Take care. Do not forget to post the answers in the comment section below. This was Shreyas here, your physics master teacher, and I was going live. Hasta la vista.